Okay, welcome back to another video, another channel. No, it's not another channel, it's the same channel. Welcome back. I'm guessing that you're watching and enjoying yourself, but good to have you here. Now, we're going to start a new topic, but again, let's start with a joke. Why did the restaurant hire the pig? Because he was good at bacon. Bacon. Okay, bacon. Okay. Now, hopefully our screen shares. Here we go. A little bit slow, but we're getting there. Are you guys getting a black screen? Because I'm getting a black screen. Well, basically, we're starting a new topic. It's going to be further calculus. And so what we're doing here is basically the first step here is we're going to learn how to differentiate and integrate inverse trig functions. Okay, so there we go. We're here. We're good. So we're learning how to differentiate inverse trig functions. So these here are going to be in your, well, not these three, but these are the formulas. And I'm not going to take too much time on these. I'm just going to show these to you. You can write them down if they're helpful to you. But this is kind of like the main form. The first one here is, I guess, your main form. If you just have a singular x and it's quite simple. This second one here is if you have, some sort of ax plus b or 2x plus 1 or 3x plus 7, something going on there. It's going to start looking like this. Now, the bottom one is probably the one that you're going to need to get familiar with, because that bottom one here, this one is the one that comes up on your reference sheet. Okay, so that's the one you need to understand how to do. Now, I'll just quickly talk about the first one, sine, and then I'll show you the rest. So if we differentiate our inverse sine, and there's a function on the inside, your derivative of that function comes out on top, and then you have in a square root underneath 1 take away the square of that function. Okay, now we'll go through some examples to make that clear. But again, that's what it is. Now, here we've got cosine. You'll notice here that cosine is basically the same thing as sine. The only difference now is that it's negative. Okay, that's because cosine and sine are very, very similar, but it's just one will be the negative of the other in this case. So again, the bottom one here, that's the only one you'll be given in your reference sheet. The other ones are helpful. It's just going to be your derivative up the top, and then 1 take away your function squared under a square root on the bottom. Okay. Tan. Now, of course, tan is always the black sheep of the family. Tan is going to be a little bit different. You'll notice very quickly that there is no square root. That's the main difference here. Okay. And instead of minus, we've now got plus, because tan, always black sheep. So, and again, this bottom one here, that's going to be the one that you are given in your reference sheet. And that's the one I want you to get familiar with. Okay, so I've just got 2 questions here, because once you know how to differentiate, all the questions that they will ask in terms of differentiation, they can ask here. So for example, gradient of the tangent, equation of the tangent, equation of the normal, gradient of the normal, all that kind of stuff they can ask that relate to differentiate. Now, because it's not a lesson on that, I'll leave that for another day. But let's just talk about differentiating, and I'll do a couple examples. Let's do y equals sine inverse 2x plus 1. So for here, your y dash, and I just remember it's going to be my, so again, let's talk about this one. That there becomes my fx, right? So my fx, or my function inside, becomes 2x plus 1. And so f dash x just becomes my 2. So that means it's going to be 2 on top for me. And then it's going to be the square root on the bottom, 1 minus fx squared. So it's going to be 2x minus 1 squared. And that there is, I'm happy to leave that for my answer. That is my derivative. Okay. It's nice, kind of gets rid of the sign, puts us into terms of x, which is nice. And just so you can see what would happen if I went y equals to, let's go cos inverse 2x plus 1. Now we know cos and sine are very similar. Y dash this time is just going to equal the negative version. So it's going to be negative 2 on, again. Sorry, I made a mistake here. That should be plus 2x plus 1, because it's the same as my function. So it'll be 1 minus 2x plus 1 squared. Okay. And tan would be the only one that's different. I'm going to see if I can fit it here. Tan inverse 2x plus 1. Now, tan means that you're not going to have a, tan means you're not going to have the square root on the bottom, and it's going to be plus. So in this case here, you're going to have our derivative, which is f dash x, which is 2, all over 1 plus 2x plus 1 squared. Didn't plan to give you all those, but I did. All right, find the gradient of the tangent. Okay, gradient of the tangent. That means we need to find y dash and sub in point of interest, or the x coordinate, which in this case is x equals 0. So let's do this, and let's go first things first. Y dash equals 2, and I'm going to go here. It's going to be f dash x. So in this case, my top here will be half, because that's the derivative of x over 2. It'll be a half, and it'll be 1 plus fx squared. So in this case, our function is x on 2, and I'm going to square it. So in that case, it just becomes 1 on 2 all over 1 plus x squared on 4. Okay, now I'm going to clean that up because there's too many fractions going on for me. There's going to be 1 over 2 times 1 plus x squared on 4. And that was a horrible line, but you get the point. I'd be happy to leave it like that. All right, you can clean it up a little bit more. 1 over 2 plus x squared on 2. Yep. Is there too many fractions? Maybe I should clean this up a little bit. I should, shouldn't I? Okay, 1 on 2 multiplied by 1 on, and this is going to be I'm going to expand the brackets. No, I'm not. 1 on 2 times 1 on 4 plus x squared on 4. All right, and so this will be the same thing as a half times by 4 on 4 plus x squared. And there you go. That's going to be a little bit cleaner. So it's going to be 2 over 4 plus x squared. So that there, long arithmetic's kind of gross. I didn't want it to take that long, but it's just a little bit of arithmetic. If you are happy to differentiate, that is the whole topic of this topic. Okay, well, that's it for today. I'll let you guys go and enjoy doing math. All right, bye-bye.